Well, welcome back. So we've studied segments, and now we're going to move on and we're going to study angles. Segments are basically one-dimensional shape, and now we're going to add a second dimension, and we're going to study angles. So let's take a look at this very basic shape called an angle. And as we do so, remember, we're looking at this two different ways. We want to look at just the shape in general, and then we want to look at the shape with measurements. So, before we get into an angle, we have some more terms to define, and I know that defining terms is very boring, and I know it kind of takes a while, but this time you have guided notes, so use your guided notes, pause the video, draw pictures, write down the definitions so you have everything you need, so when you start the homework, you can just look at your notes and everything you need is right there. So, I know it's very boring to just write down definitions, but we'll whip through those as quickly as we can and get into some really good problems. Okay, so time for some more vocabulary. Again, we need to be able to communicate back and forth talking about the same things. And our very first word is kind of a big word. It's called collinear. Remember, the prefix co means same. Linear means line. So collinear literally means points that lie on the same line. Now here's an example, and again you're going to want to pause the video and copy down this picture so you have it in your notes. You can see here that I have designated 5 very specific points in this picture. And if I want to explain how the word collinear is used, I wrote down 3 separate sentences. Points A, B, and C are collinear. They are on the same line. Points C, D, and E are collinear. C, D, and E are on the same line. And the last sentence, I think sometimes it's just as important to have a non-example as it is to have an example. Points A, B, and E are non-collinear. They are not on the same line. So, remember, today's goal is to talk about angles. And with this picture, you ought to kind of be able to see why the word collinear is kind of important to us. Let's move on and talk about array. Array is basically an infinite set of points, meaning it goes on forever, that extends forever in one direction from a starting point. Rays are always named by using 2 points. Remember, that's how we name segments, that's how we name lines. But the difference is, when you name a ray, the starting point has to come first. So when we named segments, it didn't matter which point you started with. The left point, the right point, the upper point, the lower, it didn't matter. You could do it either way. But with rays, you have to start with the starting point. This ray that starts at A and goes through B can only be called ray, notice the ray symbol, AB. Okay, so now that we've defined collinear and now that we've defined ray, we can get into angles. So here we go with angles. The definition of an angle is it's a geometric object formed by 2 rays that share a common starting point. And that common starting point is called the vertex. Right here. So point I in this angle is called the vertex. It is the same shared starting point for ray IJ and for ray IM. Now, there are 3 different ways you can name an angle. And this is really important you get this down because as our pictures get more complicated and I want you to look at a certain portion of that picture, it's very important we are using the same words to describe where we are in that picture. So the first way to name an angle is probably the most popular way, and it's by using 3 letters. You name an angle using 3 letters, but the vertex has to be in the middle. So this black angle over here could be called, well, it could be called one of 2 things. We could call that angle JIM, notice the vertex I is in the middle, or you could call it angle MIJ. Either one is fine, we just have to make sure the vertex is in the middle. Now, the second way you can name an angle is just using the vertex. And that's assuming if there is only one angle with that vertex. So this black angle over here, we could just call it angle I, because it is very clear which angle I'm talking about. Angle I, I'm naming it only by the vertex. But there's a but, and it's a pretty big one. So what you have to be really careful of in this scenario is, look at this red picture. Do you notice all the different angles we have in this picture? None of these angles can be called angle O, since there are so many angles in that picture that use O as the vertex. For example, angle BOA. Is that angle O, or is it angle BOC? Or is it angle AOC? Or is it angle DOC, or angle COE, or angle DOE? There's so many different angles that use that as the vertex. And, oh, this is embarrassing. I said the picture at the right. It's obviously the left. How embarrassing. Okay, just ignore that. And finally, the third way you can name an angle is just by using a number. So, for example, if I came through here and I put a 1 right here, I could say angle COE is angle 1. And I could put a 2 right here. And I could say angle COD is angle 2. And this is angle 3. And I could call angle BOA angle 4. And I could call angle AOE angle 5. So if you put a number right down here near the vertex, you could call this angle, for example, angle 2. Angle 2. Okay. So now we know how to name angles. Let's take a little time out, and if you look at your notes on the second page there, here's some practice problems. I have this picture drawn, I have points named, and I have angles numbered. So I'd like you to go through and see if you can fill in these blanks. So pause the video, give this a try, and then come back. Hey, welcome back. I hope you're pausing the video and you're trying it on its own. Remember, this is a great learning opportunity for you to practice, and if you get it wrong, correct it and figure out what you did wrong. Angle MZL. Well, if you put your pencil on M, that's the first point, you trace along this line to Z, that's the vertex, and along this line to L, MZL, you'll notice you traced out this angle right here, which we call angle 1. Angle NZP. Again, put your pencil on N and just trace. Go from N to Z to P. N, Z, P. That's this angle. That's angle 3. Number 3. L, Z, Q. L, Z, Q. Angle 5. Angle 2 is the same as what angle? Well, angle 2 is right here, and if I trace the sides of 2, I might go N, Z, M, or I could reverse it and go M, Z, N. Same angle. Just make sure the vertex is in the middle. And if I take angle 3 and I add it to angle 4, I get what? Well, angle 3 plus angle 4. Angle 3 is here. Angle 4 is here. That forms this big angle. Don't call it angle 7. It is called angle NZQ. And again, one thing that might help is here's angle 3. I can color this angle. Oh, geez. I can color that angle red. Let me fix this little blurb out here. And then angle 4, I could color purple. You know, that's this angle right here. I could color it purple. So what angle is both red and purple? Well, it starts at N, it goes to Z, and it hits Q. That's angle NZQ, or you could reverse it. So here are some more practices. Why don't you work through the vocabulary practice, problems 1 through 6 on your own, and then come back to the video and see how you did. Hey, welcome back. I hope that you named the angle to the right correctly using 3 letters. You could name it ABC or CBA. Of course, if you were allowed to use 1 letter, you could. This is clearly angle B. There's no confusion. And that would be done in number 2. It's angle B. Okay, again, if you didn't pause, pause now and do problems 3 through 6. So 3 through 6, I asked you to find the angle that's colored green. You can see that that's there. The blue angle could be one of these two. Again, IOR and angle ROI, same angle. This purple angle right here, purple. And finally, number 6, when you take the orange and the yellow, now the orange starts right here. It takes this ray and it rotates it over to there. The yellow picks that ray up and it rotates it over to there. So we started with this way, we ended with that ray. What angle does that produce? Well, it produces HOA or AOH. Now, you have one more batch where we actually are adding some numbers in. So this would be a great time to pause the video and then come back in when you're done trying these 3 problems. Okay, welcome back. Hopefully you read this little comment to the side that anytime you see an angle named with an M in front of the angle symbol, it means the measure of that angle. And you'll see that coming up in the next examples. So this one, kind of a very basic problem. We know the angle DOG is made up of 2 angles. It's made up of this angle right here, which is 28 degrees. It's made up of this angle right here, which is 72 degrees. And so we would say it's the sum of those 2 angles, or 100 degrees. Getting a little bit more complicated. Now I want you to find the measure of angle CAT. And again, that's that symbolism we just saw. M angle means the measure of the angle if the measure of angle CAS is 135 degrees. So angle CAT is unknown. I call that X. And I know that the measure of angle CAS, that's this big one, and I'm going to put this giant big arc here. That whole thing is 135 degrees. So we can get a mathematical equation from this. What we can do is we can say that if you take 72 and you add it to X, you get 135. And if you solve this, you get X is 63. Now remember, when you're measuring an angle, what you're measuring is how much rotation occurred to take you from one ray to the other. So in this particular instance, to go from this ray to that ray, we traveled X degrees. To go from this ray, AT, to this ray, AS, we traveled 72 degrees. And we know that the whole rotation was 135. Now, our more complicated problem is the last one, where we're really going to dive into some algebra skills. So what I did is I came over here and I labeled my angles in my picture. I think that's very important. So this angle right here, this little red angle, is 5x minus 7. And again, that 5x minus 7 is the rotation from one side to the other. This blue angle right here, this blue angle, I'll just kind of color the vertex in right here. This blue angle is 3x plus 4. And that's the rotation from CS to OS. And the whole thing, look at this, angle CSW. So going from C all the way to here, that's the 6x plus 21. I am a huge fan of using color to help you see relationships. And so if we break this down, you see that the blue angle plus the red angle gives us the entire purple rotation. And using a little bit of algebra, why you can find that x is 12. And knowing x is 12, you can put 12 back in for x, and you can get that x, being 12, gives us CSW is 93 degrees. So, again, color might help you see these relationships, but what we've learned here is the angle addition postulate. Just like the segment addition postulate, the sum of the parts is equal to whole. A plus B equals